Hey guys, Assalamu alaikum. Today we are going to start a next topic, and that is after purification techniques. We have just discussed this thing earlier that there are two types of parts for this chapter. One type is dealing with purification techniques, whereas the other is dealing with separation techniques. We have discussed about the purification techniques. One of the purification technique was melting point, which was used to check the purity in a solid, whereas the second technique was boiling point, which was used to check the purity of a liquid. And the third was paper chromatography, which is particularly used to check the purity of different pigments, purity of different types of foods, purity of different types of medicines. Sometimes examiner is saying that something is colored, how you can separate it into its pigments and into its components. The point is, with the help of paper chromatography, and you can use this paper chromatography to identify different type of the components present in a substance as well. So paper chromatography is the key in which we can find out the purity of different substances. All right, now we are on the second part of this chapter, and that is called as separation techniques. How we can separate the two substances from each other, how we can look into this thing that this is one component and this is the other component without wastage of any of the component, without destroying, without disturbing the amount of any component, how we can separate the two components. All right, so this is separation technique. I'm writing here separation processes or separation techniques. All right. Okay. So there are basically three categories in which we are going to study. So in the start, I'm telling you solid separation. I mean to say how we can separate one solid from another solid. All right. So number one thing which I'm going to tell you is about magnetism. Okay. Number two is solubility. And number three is sublimation. All right, let's have a look on magnetism. For example, there are two or more than two solids, and one of the solid is attracting towards a magnet. It has an ability that it can be attracted towards a magnet. Just consider the mixture of three metals. One of them is gold, second is silver, and third is iron. We already know this thing that iron is a magnet attracting metal. It can be attracted by a magnet. So in this way, by the help of a magnet, we can attract iron from the rest of the two metals. Okay. Iron is not only the magnet attracting metal, there are other metals as well, which are not very much famous. For example, niobium, Nb. Nb is the symbol for niobium, and it is a metal which is attracted towards magnet as well, but this is not very much famous or a commonly saying metal. But remember this thing that whenever examiner is going to give you any new type of a substance, at that time he will definitely mention this thing that this is a metal or this is a substance which is attracting towards magnet. So remember this thing that whenever magnet is there, it means that one of the substance will definitely be attracting towards a magnet. Just consider an industry, and that industry is dealing with irons. Let's suppose it is dealing with the manufacturing and stuff related to iron. Okay, so, for example, there is lots of waste that industry is throwing out of it every day, and that industry definitely containing that waste, definitely containing some iron components as well. How we can save that iron? Obviously, with the help of this magnetism technique, guys. You all are aware of this conveyor belt thingy. So now, just consider that, for example, the conveyor belt is the same which we have experienced as a for the luggage thing in on airports, in hospitals, in malls, and etc etc. So what is happening, there is a huge conveyor belt with a huge magnet on it. Instead of that scanner, there is a huge magnet on it. Huge magnet means it's a powerful magnet, and we are passing the whole thing, we are passing the whole waste of that industry on that conveyor belt. only the magnet attracting materials will be attracted by that magnet, and rest of all the solids will be considered as waste, can be thrown out of the industry. Okay, so this is how the magnetism is working, this is how a magnet is working. Okay, and then if I'm talking about number 2, this is called solubility. Okay, now, solubility, for example, I am mentioning here very clearly. For example, you have NaCl and sand. Okay. First of all, let me tell it to you very clearly that sand is SiO2. Chemical formula of sand is SiO2. I mean to say silicon oxide or silicon dioxide. Both names are correct. Now, back to NaCl. NaCl is the formula of our table salt. So we already know this thing that NaCl, called sodium chloride, is water soluble substance. Okay. So now, for example, if a mixture of NaCl and sodium and SiO2 is given to us and sand is given to us, and it is asked to separate them two, we already know this thing that sodium chloride is soluble in water, whereas SiO2 is insoluble in water. We will take the whole mixture and put it into a specific amount of water. We can dissolve it more appropriately, thoroughly, completely with the help of a glass rod. Glass rod is nothing. When I was introducing you to the syllabus related to apparatus, I have discussed this thing as well in the previous YouTube lectures. It is present that a glass rod is basically a rod made up of glass, a thin rod made up of glass, and it is used for stirring, for mixing the whole content. So when sodium chloride and sand will be there and it is added to water, what will happen? Sand will settle down at the bottom, whereas sodium chloride will become part of that water. Okay, now what will happen? Sodium chloride will become part of that water. It means that when we use when we will try to pass this whole mixture through a filter paper, what will happen? I'm going to draw this diagram here. Okay, and this is called filter funnel. Okay, and this is how it is, and here is the solid that is called the residue, and that is sand here at the top, and here the bottom, it is the sodium chloride solution. I'm writing here NaCl solution will be here, which is called as filtrate. When I will teach you the topic of filtration, inshallah, at that time I will discuss this as well. It is called filtrate, and the top thing that which is at the top of the filter paper is called residue. Okay, this is called residue. Okay, so now we can separate the two. Okay, but in this case, sodium chloride is not obtained anywhere. Okay, we have to add more water through that sand so that all the particles of sodium chloride can pass through, that can be collected at the bottom as a filtrate. Okay, now that sand can be dried in the layers of the filter paper to obtain pure sand. Okay, done. Okay, now how we can obtain sodium chloride from sodium chloride solution? Okay, so this is the container called beaker. We are now going to shift this solution into another container called china dish. Okay, and that china dish is placed on the top of a tripod stand, whereas this is called a bunsen burner, which is used to supply the heat. And what will happen? This is the solution through which sodium chloride will be obtained. It will be heated, and you can see that water vapors are forming and water will be evaporated. Okay, so when very small amount of water is left, you can left this whole china dish in on a colder part of the lamp, left it to cool. As a result, what will happen? All the water content will be removed and only sodium chloride will be left. In this way, sodium chloride and sand can be separated 100%. All right, guys. Thank you very much. We are going to continue with the topic of sublimation, inshallah. Take care of yourself. Allah